Hello students, in this lecture we will see some of the indices and numerical related to this chapter, that is plasticity characteristic of soil. First index is Plasticity Index. It is denoted by IP or PI. Okay, it is the range of water content over which the soil remains in the plastic state. IP is given as liquid limit minus plastic limit. Let us try to understand it from this diagram. This is liquid limit and we have to subtract plastic limit. Okay, so what we will get? We will get this. Okay, this is what we are going to get. So this is a range of water content. Okay, this is the range of water content in which the soil will be in plastic state. That is what it is written here. Plasticity index is the range of water content over which the soil remains in the plastic state. Okay, when the plastic limit is greater than the liquid limit, IP is reported 0 and not negative. Okay, this must be remembered. IP is reported 0, not negative, when the plastic limit is greater than the liquid limit. Okay, when this PL is greater than liquid limit, that is liquid limit will be on the left side of the plastic limit. Next we will see liquidity index. It is denoted by IL or LI. It is also known as water plasticity ratio. IL is given by, that is liquidity index is given by water content of the soil in the natural condition. Okay, water content of the soil in natural condition minus WP, that is plastic limit, divided by IP, that is plasticity index, into 100. Okay, the liquidity index of soil indicates the nearness of its water content to its liquid limit. Okay, जो भी सॉइल में वाटर नेचुरली अवेलेबल है तो वो वाटर कितना नियर है लिक्विड लिमिट ऑफ द सॉइल के. ठीक है, लिक्विडिटी इंडेक्स यही बताता है. ओके, एंड नेगेटिव वैल्यू ऑफ IL लिक्विडिटी इंडेक्स indicate water content is smaller than the plastic limit. Okay, next is consistency index. It is denoted by IC or CI. It is also known as relative consistency. Okay, it is defined as IC, that is consistency index, is WL minus W upon IP into 100. It is liquid limit minus W is water content in the natural state of the soil, divided by plasticity index into 100. Okay, it indicates the firmness of the soil. Consistency index, it indicates firmness of the soil. It shows the nearness of the water content of the soil to its plastic limit. Okay, earlier it was nearness of the water content to the liquid limit. Okay, in liquidity index case, but in this case nearness of the water content of the soil to its plastic limit. Okay, a consistency index of greater than 100% shows semi solid state. Okay, and negative value of IC indicates water content greater than liquid limit. Okay, now see, IL, that is liquidity index, plus consistency index will always give 1 or 100%. Okay, that means higher the value of IL, that is liquidity index, lower will be the value of IC, and vice versa. Okay, let us now see flow index. It is the slope of the flow curve obtained between number of blows and water content in Casagrande's method. कैसाग्रेंडे मेथड हम लोग क्यों यूज़ करते थे, किसके लिए निकालने, किस चीज़ के लिए यूज़ करते थे? लिक्विड लिमिट निकालने के लिए हम लोग कैसाग्रेंडेज मेथड और कैसाग्रेंडेज टूल यूज़ करते थे। ठीक है, उसमें आपको याद होगा कि नंबर ऑफ ब्लोज होते थे और वाटर कंटेंट होता था। ठीक है, उसके बीच एक प्लॉट तैयार किया जाता था। ठीक है, जिसमें नंबर ऑफ ब्लोज को हम लोग लॉग स्केल पे रखते थे और वाटर कंटेंट को नॉर्मल स्केल पे रखते थे ऑन द वाई एक्सिस। ठीक है, वही प्लॉट यहाँ आपको दिखाया जा रहा है। ठीक है, यू कैन सी हियर this is number of blows at the bottom and it is water content. okay, यहाँ पर आप देखेंगे कि N1 ब्लोज दिए गए उस समय वाटर कंटेंट W1 आया। ओके, ठीक है, जब N2 ब्लो दिए गए तो उस समय वाटर कंटेंट W2 आया। ठीक है, अब मैं और N3 ब्लोज देने पर वाटर कंटेंट W3 आया। ओके, और इस तरह अलग अलग नंबर ऑफ ब्लोज के लिए अलग अलग वाटर कंटेंट हमें मिलता है। हमने क्या किया, एक ग्राफ प्लॉट किया जो कि स्ट्रेट लाइन कुछ इस तरह शो कर रहा है। ठीक है, अब फ्लो जो हमें यहाँ फ्लो इंडेक्स चाहिए वो क्या होता है, तो इट इज़ द स्लोप ऑफ फ्लो कर्व। मतलब ये जो फ्लो कर्व हमें मिला है ना, इसी का स्लोप अगर मैं निकाल दूँ तो हमें फ्लो इंडेक्स मिल जाएगा। तो बताइए इस कर्व का कैसे मैं स्लोप निकाल सकता हूँ। इट इज़ गिवन बाय W1 minus W2 means this. okay, W1 minus W2 divided by N2 माइनस N1। ये बचपन से हम लोग सीखते आ रहे हैं, बचपन इन द सेंस 11th 12th हमने सीखा है। ठीक है, बट इट इज़ not a normal scale, it is log scale. okay, hence IF is given by W1 minus W2 divided by log base 10 N2 minus log base 10 N1. okay, करेक्ट। ठीक है, तो हमने जाना कि फ्लो इंडेक्स इज द स्लोप ऑफ द फ्लो कर्व। ओके, नाउ फिजिकली इसका क्या रेलेवेंस है। The flow index is the rate at which a soil mass loses its shear strength with an increased water content। जैसे जैसे आप पानी की मात्रा या वाटर कंटेंट सॉइल में बढ़ाते चलेंगे तो किस रेट से सॉइल अपने shear स्ट्रेंथ को लूज करेगा, वही दर्शाता है फ्लो इंडेक्स। ओके, the soil with greater value of flow index has steeper slope and possesses lower shear strength। मतलब क्या हो गया, ज़्यादा वैल्यू अगर फ्लो इंडेक्स का है तो shear strength कम। ओके, नेक्स्ट इज टफनेस इंडेक्स। टफनेस इंडेक्स इज डिफाइंड एज IP upon IF। what is IP? IP is plasticity index and IF is flow index. The ratio of plasticity index to flow index is IT, that is toughness index. okay, it measures the shearing strength of the soil at plastic limit। प्लास्टिक लिमिट पे सॉइल का क्या shear स्ट्रेंथ है उसको मेजर करके बताता है कौन, टफनेस इंडेक्स। ओके, नेक्स्ट इज सेंसिटिविटी। व्हाट इज सेंसिटिविटी? देखिए, कोई भी एक कोहेसिव सॉइल है, अगर नेचुरल स्टेट में वो है तो उसका कोई एक सर्टेन स्ट्रक्चर होगा। ठीक है, लेकिन उस सॉइल को जब हम डिस्टर्ब करते हैं तो उसका स्ट्रक्चर भी डिस्टर्ब हो जाता है और इसके कारण रीमॉडलिंग ऑफ सॉइल ऑकर्स एंड इंजीनियरिंग प्रॉपर्टीज जो सॉइल के हैं वो चेंज होते हैं। ठीक है, हेंस सेंसिटिविटी ऑफ सॉइल इंडिकेट्स इट्स वीकनिंग ड्यू टू रीमॉडलिंग। सॉइल का जब रीमॉडलिंग हो रहा है, उसको नेचुरल स्टेट से दूसरे स्टेट में लाया जा रहा है, ठीक है, तो रीमॉडलिंग के कारण जो उसमें वीकनिंग हो रही है वही है सेंसिटिविटी। ओके, एंड इट इज़ गिवन बाय QU U divided by QU R, that is unconfined compressive strength divided by confined compressive strength after remolding. okay, undisturbed soil and divided by remolded soil। दोनों ही केस में unconfined compressive strength soil का क्या है, अगर इसका रेशियो आप ले लेंगे तो आपको मिल जाएगा सेंसिटिविटी ऑफ सॉइल। ओके, फॉर मोस्ट क्ले सेंसिटिविटी लाइज बिटवीन 2 and 4. सेंसिटिविटी की वैल्यू क्या होती है क्लेज के लिए? 2 से 4 के बीच लाई करती है. ओके, नेक्स्ट इज थिक्सोट्रॉफी. लेट अस सी व्हाट इज थिक्सोट्रॉफी. अब देखिए, जो रीमाउल्डेड सॉइल है आपका, अगर उसको हम कुछ देर तक स्थिर छोड़ देते हैं और विदाउट लॉस ऑफ वाटर, तो वो कुछ स्ट्रेंथ को, सारे को तो नहीं लेकिन कुछ स्ट्रेंथ को रिगेन कर लेता है. ठीक है. Okay, the gain in the strength of the soil with passage of time after it has been remolded is called thixotrophy. तो thixotrophy क्या हो गया? Regaining of the strength of the soil. Okay, after remolding. तो ये thixotrophy इस तरह डिफाइन होता है. Okay, next is activity of soil denoted by A. Activity of a soil is the ratio of plasticity index and percentage of clay fraction. जो भी आपके पास सॉइल है उसमें क्ले फ्रैक्शन कितना है उसका परसेंटेज आप निकाल लीजिए. ठीक है. और IP दैट इज प्लास्टिसिटी इंडेक्स डिवाइडेड बाय F दैट इज क्ले फ्रैक्शन, ये आपको एक्टिविटी दे देगा. ठीक है. एक्टिविटी का मतलब क्या है? एक्टिविटी इज द मेजर ऑफ वाटर होल्डिंग कैपेसिटी. फिजिकली क्या इसका मतलब है? वाटर होल्डिंग कैपेसिटी ऑफ क्ले सॉइल. कितना वाटर होल्डिंग कैपेसिटी है ये एक्टिविटी से पता चल जाएगा. ठीक है. ये जो डायग्राम है इसमें मैं वापस आऊँगा जब आपको पता चल जाएगा कि मॉन्ट मोरेलो नाइट क्या होता है, इलाइट क्या होता है, काओलाइनाइट क्या होता है. ये नेक्स्ट चैप्टर में हम लोग देखेंगे. उसके बाद वापस इस डायग्राम पे मैं आऊँगा. ठीक है. एक्टिविटी एंड सॉइल टाइप. तो एक्टिविटी अगर 0.75 से कम है तो उसको इनएक्टिव सॉइल बोलते हैं. अगर 0.75 से 1.25 है तो नॉर्मल सॉइल बोलते हैं. और अगर एक्टिविटी ग्रेटर देन 1.25 है तो सॉइल को एक्टिव सॉइल बोलते हैं. ठीक है. ओके. ये जो आपको यहाँ इतनी चीज़ें दिख रही है ना, मैं इस पर वापस आऊँगा. ओके. नाउ ये जो कंसिस्टेंसी लिमिट्स और कंसिस्टेंसी इतना हम लोग पढ़ लिए, क्या इसका यूज़ है भाई, ये भी तो जानना पड़ेगा ना. ठीक है. तो यूजेस जो यहाँ लिखे गए हैं आप इन्हें देख लीजिएगा. एक आध मैं बता रहा हूँ कि एज द पार्टिकल साइज डिक्रीजेस, जैसे जैसे पार्टिकल साइज डिक्रीज होता है सॉइल का, बोथ लिक्विड लिमिट एंड प्लास्टिक लिमिट इंक्रीजेस, बट लिक्विड लिमिट जो है इंक्रीज करता है ग्रेटर रेट. इस डायग्राम से ये चीज़ आपको दिख रहा है. ठीक है. हेंस प्लास्टिसिटी इंडेक्स दैट इज द डिफरेंस बिटवीन द लिक्विड लिमिट एंड प्लास्टिक लिमिट इंक्रीज एट अ रैपिड रेट. जैसे जैसे पार्टिकल साइज डिक्रीज कर रहा है तो पी की वैल्यू इंक्रीज हो रही है रैपिड रेट पे. ठीक है. PI is a measure of amount of clay in the soil. Plasticity index क्या है? Amount of clay कितना है सॉइल में. clay का मतलब क्या? 2 माइक्रोन से छोटे. ठीक है. तो वो दिखाता है प्लास्टिसिटी इंडेक्स. ठीक है. अब देखिए मेन चीज़ यहाँ जो ये नेक्स्ट जो मैं टॉपिक पढ़ाऊँगा उसमें आपको ये दिखेगा भी. द मेन यूज ऑफ कंसिस्टेंसी लिमिट्स इज द क्लासिफिकेशन ऑफ सॉइल्स. ओके. ये है मेन कंसिस्टेंसी लिमिट्स का यूज़. ओके. कुछ और पॉइंट्स यहाँ लिखी हुई हैं जो आप लोग देख लीजिएगा. ओके. वन इज़ कंप्रेसिबिलिटी ऑफ सॉइल इंक्रीजेज विथ इंक्रीज इन लिक्विड लिमिट. इसको भी ध्यान में रखना चाहे तो रख सकते हैं. दैन श्रिंकेज इंडेक्स इज प्रोपोर्शनल टू परसेंटेज ऑफ क्ले साइज फ्रैक्शन. ओके. अब हमारा अगला जो काम है वो है कुछ न्यूमेरिकल सॉल्व करना इस चैप्टर से रिलेटेड. ओके. सो आइए हम लोग अब कुछ न्यूमेरिकल्स देखते हैं चैप्टर से रिलेटेड. लेट अस नाउ ट्राई टू सॉल्व दिस न्यूमेरिकल. अ सॉइल हैज़ ए लिक्विड लिमिट ऑफ 25% and a flow index of 12.5%. Okay. If the plastic limit is 15%, determine plasticity index and toughness index. Okay. Also, if the water content of the soil in its natural condition in the field is 20%, find the liquidity index and relative consistency. Okay. So let us see how we can solve it. First and the foremost thing, given. Okay, let us write the data which has been given to us. Liquid limit is 25%. Flow index is 12.5%. plastic limit is 15%. Determine plasticity index and toughness index. Okay, we have to find plasticity index and toughness index. Okay, we have to find these two. Also, if the water content of the soil in its natural condition in the field is, that is, water content has been given as 20% when the soil is in its natural condition. Okay, also we have to find liquidity index. Okay, and relative consistency, that means consistency index. Okay, so there are altogether 4 items that we need to find. Okay, let us see how can we proceed. Firstly, we know that we need to find IP. Na? IP is given by liquid limit minus plastic limit. We know this. Okay, alternatively we can also write this like this. Okay, we can also write like this. Okay, so liquid limit minus plastic limit. What is liquid limit? Liquid limit has been given as 25% minus what is plastic limit? It is 15%. Okay, so the difference is 10%, hence IP is 10%. Okay, so first thing we have found. Next, we need to find toughness index. We know toughness index is given by IP divided by IF. Okay, IP plasticity index, IF flow index. Okay, what is IP? Has it been given? No, but we have just found it out. So it is 10. Okay, what is flow index? It has been given in the question, so it will be 12.5%. okay, so it will be 0.8, or you can also say it is 80%. okay, next is we need to find IL, that is liquidity index. IL, that is liquidity index. It is given by natural water content minus WP, that is plastic limit, minus IP, that is plasticity index, into 100. Okay, so what is the water content in natural condition? So W is given as 0.20 minus 0.15. IP, that is plasticity index, is 0.10, as we have already found it. Okay, into 100. So the answer will be, after calculation you will find the answer is 50%. Okay, what is next? Next is IC, that is consistency index or relative consistency. Okay, we know that it is represented by WL minus W upon IP into 100. Okay, what is the value of liquid limit? Liquid limit is 25%. What is the value of natural water content? It is 20%, 0.20, divided by IP. What is the value of IP? It is 10%. okay, so it will be equal to 50% again. Okay, let us now see another question. The following index properties were determined for the two soils A and B. Okay, there are two soils, soil A and soil B. Okay, and some of the index properties of the soil has been given here. Okay, liquid limit for A is 65. Okay, for B it's 35. Plastic limit, water content, specific gravity is 2.70. definitely these are in percentage. Okay, specific gravity of solids 2.70 and 2.65, and degree of saturation is 100% for both the cases. Okay, now which of the two soils contains more clay? किस सॉइल में ज़्यादा क्ले है? ग्रेटर बल्क डेंसिटी कौन से सॉइल का है? कौन से सॉइल का ग्रेटर ड्राई डेंसिटी है और किसका वाइड रेशियो ज़्यादा है? ओके, वी हैव टू फाइंड ऑल दिस थिंग्स. ओके, so let us see how we can get the solution. See, for solving A, that is which of the two soils contains more clay, how can we say which soil contains more clay? We will find plasticity index. Okay, plasticity index, it is given by liquid limit minus plastic limit. Okay, now for soil A, if I write A here and B here, for soil A, what will be the plasticity index? It will be liquid limit, that is 65 minus plastic limit is 25. Okay, so it will be equal to 40%. Okay, for soil A. For soil B, plasticity index will be equal to liquid limit, that is 35% minus plastic limit, that is 20%. It will be equal to 15%. Okay, why we have found here PI, plasticity index? To know plasticity index indicates clay, है ना, how much clay a soil contains, that is indicated by a plasticity index, and hence we have gone for plasticity index. Okay, now next question is which has greater bulk density? Okay, and which has greater dry density and which has greater void ratio? Let us first try to find void ratio. Okay, void ratio we can find E is equal to Wg upon S, but S for both the cases is 1. Okay, or 100%. So E for soil A will be equal to W into G. What is the water content for soil A? It is 0.35 into value of G is 2.70. Okay, so E after calculation you will find that it is 0.945. Okay, and for soil B, E will be equal to 0.25 into 2.65. Using calculator you will find that it is equal to 0.663. Okay, so we have now E with us. Okay, now let us find dry density. So it is not actually B, it is actually question number D. Okay, let us now try to find dry density. Dry density is C. We know rho D is equal to G rho W upon 1 plus E. So for soil A, rho D will be equal to 2.70 into 1. Okay, upon 1 plus E, that is 1 plus 0.945, and it will be equal to 1.388 gram per ml. Okay, for soil B, it will be equal to 2.65 into 1 upon 1.0663, so it will be equal to 1.594 gram per ml. Okay, last is which is B. Bulk density, we have already studied that dry density is equal to bulk density upon 1 plus water content. From here we can say that bulk density is equal to dry density into 1 plus water content. Okay, so density will be equal to, what is the dry density for soil A? It is 1.388. 1 plus water content is, for soil A, water content is 0.35, so it will be equal to 1.35. It will be equal to 1.874 gram per ml. Okay, and same for soil B, it will be equal to 1.594 into 1 plus water content is 25%. Okay, it will be equal to 1.992 gram per ml. Okay, now the question is, which of the two soils contains more clay? The one having greater plasticity index will have more clay. Okay, has greater bulk density. Which of the two soil has greater bulk density? We know now. Greater dry density, that also is known to as. Greater void ratio, no. Okay, so this is how we can solve this question. Let us now see another question. A sample of clay has the liquid limit and shrinkage limit of respectively 60% and 25%. If the sample has a volume of 10 ml at liquid limit and volume of 6.40 ml at shrinkage limit, determine the specific gravity of solids. So G is what is required in this question. Okay, let us see how can we proceed. Okay, let us assume that ms be the mass of solids. Okay, and it is in gram. Okay, now tell me, what will be the mass of water at liquid limit? What will be mass of water at liquid limit? What is liquid limit? Liquid limit is a water content, and we know water content is equal to, liquid limit is a water content, and we know water content is mass of water by mass of solids. Okay, and this liquid limit has been given here as 0.60, that is 60%, is equal to mass of water upon mass of solids. So from here we can say that mass of solids into 0.60, that is mass of water. Okay, that is what I am asking. What is mass of water at liquid limit? So it will be equal to 0.60 ms. Okay, and what is mass of water at shrinkage limit? In the same manner we can say it is 0.25 ms. Okay, now can you tell me what is the mass of water lost between the liquid limit and shrinkage limit? Mass of water lost between liquid limit to shrinkage limit. How much water has been lost? So we can easily say it is 0.60 ms minus 0.25 ms, and it will be equal to 0.35 into ms. Okay, so this is the mass of water lost. What is the reduction in volume? What is reduction in volume? It will be equal to 0.35 ml. How is it possible? Because density of water is 1 gram per ml. Okay, but we have written here reduction in volume is 0.35 ms, but we know that reduction in volume is 10 ml minus 6.40 ml. Okay, so now we can write actual reduction in volume will be equal to 10 minus 6.40, that is 3.60 ml. Now you know very well that we have to equate. Okay, equate this and this, hence 3.60 is equal to 0.35 ms. From here we can get ms is equal to 10.29 gram. Okay, now from here we can solve it in two different ways. Okay, up to here I think so that it is clear. Okay, from here it can be solved in two different ways. Okay, now what is the mass of water at shrinkage limit? Mass of water at shrinkage limit. Okay, is equal to 0.25 into ms, that is 10.29. okay, so it will be equal to 2.57 gram. Okay, so can you tell me now volume of water? When we know the mass of water at shrinkage limit, then what will be the volume of water at shrinkage limit? It will be equal to 2.57 ml as rho w is equal to 1. Okay, so we know now that volume of water at shrinkage limit is 2.57 ml. Okay, then what is the volume of solid particles? It will be equal to total volume at shrinkage limit minus volume of water, and it will be equal to 3.83 ml. Okay, now we know that G, that is specific gravity of solids, is nothing but mass of solids. So volume of solids means density of solids divided by density of water. So it is equal to 10.29 divided by 1, the density of water, into volume of solids is 3.83. Finally it is 2.69. okay, done. Okay, another method you can use to find this G is using the shrinkage limit. Okay, we have seen in the when we were doing this shrinkage limit. Okay, we have seen it there, and using that also we can find it. Okay, I'm talking about this formula. Okay, using this formula also we can directly find the specific gravity of solids. Okay, let us now solve another question. In an experiment for the determination of shrinkage limit, the following observations were taken. Okay, volume of saturated soil is 9.75 ml, mass of saturated soil is 16.5 gram, volume of dry soil after shrinkage is 5.40 ml, and mass of dry soil after shrinkage is 10.9 gram. Okay, so whatever we have studied in shrinkage limit, using that knowledge we can say that V1 has been given as 9.75 ml. Okay, that is, as we know that this experiment is for the determination of shrinkage limit. Okay, so V1, that is stage 1 volume, is 9.75 ml. Okay, and V2 is, that is after drying, it is 5.40 ml. Okay, Mass of saturated soil, that is stage 1, it is given as 16.5 gram, and mass of solids has been given as 10.9 gram. Okay, now we know that shrinkage limit is equal to, we have already studied it. Here we can say using this formula, okay, we have to use this formula. Okay, so using that formula, shrinkage limit is equal to m1 minus ms minus v1 minus v2 rho w upon ms. Okay, so what is m1? M1 is 16.5 gram, minus what is ms? It is 10.9 gram. Okay, minus what is v1? V1 is 9.75 ml, minus v2 is 5.40 ml. Okay, into rho w is 1 divided by ms is 10.9. Okay, so after calculation you will find that it is 0.1147, that means 11.47%. Okay, so this is what we were in need. Okay, that is shrinkage limit. Okay, so that's it for this chapter.